All right, let's talk about something that is literally all around us, but we almost never think about it. I mean, it's the foundation of our entire modern world. I'm talking about concrete. Believe it or not, it's the most used substance on Earth right after water. So let's dive in. No, seriously, just take a second and look around. The building you're in right now, the sidewalk outside your window, the bridges you drive over, those massive dams holding back entire rivers. Yep, chances are they are all built with concrete. It's this silent, incredibly strong material that's just holding our whole world together. And it just looks like, well, like simple gray stuff, right? Kind of like mud that someone left out to dry. But underneath that simple exterior, there's some really complex and fascinating science going on. So how in the world does a wet mix of sand, stone, and powder turn into something strong enough to hold up a skyscraper? Well, that's exactly what we're going to find out. Okay, so here's the plan. We'll start with a quick trip back in time to see where concrete even came from. Then we're going to break down its secret recipe. After that, we'll get into its modern-day superpowers, face some of its tough environmental challenges, and finally, we'll look at how we're completely reinventing this ancient material for the future. Sound good? Let's go. All right, first up, the world built on concrete. And you might be surprised to learn just how long we've been depending on this man-made rock. I mean, we're talking thousands of years. Yeah, this idea is definitely not new. The ancient Romans, they were absolute masters of an early version of this stuff. They used volcanic ash to build these incredible structures, like the Pantheon in Rome, that are still standing today, 2,000 years later. But the real game changer, the thing that led to the stuff we use now, came in 1824 with something called Portland cement. That was the key ingredient for the modern concrete we see everywhere. And today, when you pair it with steel, it's the undisputed king of building materials on the entire planet. Nothing else even comes close. Okay, so if this stuff is so important, what exactly is it made of? Let's get into this secret recipe for rock. Okay, first things first, let's clear up something that trips a lot of people up. You often hear people say cement when they really mean concrete, but they are not the same thing at all. The easiest way to think about it is like this. Cement is just one ingredient, kind of like the flour you'd use in a cake. It's this superfine powder that acts as the glue. Concrete, on the other hand, is the finished cake. It's what you get when you mix that cement flour with water and what we call aggregates, which is really just a fancy word for sand and gravel. And when you look at the proportions, it's actually kind of surprising, right? The vast majority of what's in concrete isn't that magic cement powder. It's mostly just aggregates, sand, gravel, crushed stone. And they aren't just filler. They are the real backbone that gives it its bulk and strength. The cement and water, they just form a paste that locks all those pieces together into a solid chunk. And this is where the real magic happens. See, concrete doesn't get hard just by drying out like a mud puddle would. No, it hardens through a chemical reaction called hydration. The moment water hits that cement powder, it kicks off a process that literally grows a complex crystalline structure from the inside out. So it's not drying, it's building itself into a solid rock. Let's zoom in a little bit on how this actually works. As soon as you add water, it starts dissolving the minerals in the cement. This creates a microscopic binding gel. The technical name is a mouthful, calcium silicate hydrate, or just CSH for short. And trust me, this stuff is the star of the show. This gel starts to grow into this dense, interlocking web of crystals. It weaves its way through all the sand and gravel, locking every single piece into one solid mass. That tiny, intricate, microscopic structure is the real secret behind concrete's incredible strength. But, basic concrete is really just the starting point. These days, we can engineer concrete to do pretty much anything we need it to do. It's got some serious superpowers. And we do this by hacking the mix with these special chemical additives called admixtures. It's pretty cool. For example, if you need to pour concrete in the freezing cold, you can add an accelerator to speed up the hardening process. Pouring in the middle of a blazing hot summer, no problem, a retarder slows everything down. You can even add something called an air entrainer, which creates these microscopic air bubbles that gives water a place to expand when it freezes, which prevents the concrete from cracking. We can even mix in industrial byproducts like fly ash to make the final product even stronger and more durable. It's totally customizable. And this brings us to the ultimate superpower, pairing concrete with its perfect partner, steel. Here's the deal. Concrete is amazing at resisting compression, being squeezed, but it's awful at handling tension, being pulled apart. It just snaps. Steel, it's the complete opposite.
So when you stick steel bars or rebar inside the concrete, you get the absolute best of both worlds. You get a composite material that is incredibly strong under almost any kind of force you can imagine. And that simple, Brian idea is the genius behind reinforced concrete.
Okay, so for all its incredible strengths, concrete has a pretty significant dark side. It comes with a heavy environmental price tag, and it all comes back to that one key ingredient, cement. This number right here is at the heart of the whole problem. To make cement, you have to heat limestone and clay in these gigantic kilns up to around 1450 degrees Celsius. To put that in perspective, that's hotter than lava from a volcano. The process uses a staggering amount of energy, and worse, the chemical reaction itself releases enormous amounts of carbon dioxide into the atmosphere. In fact, if the cement industry were its own country, it would be the third largest CO2 emitter in the entire world. That's huge. So yeah, this is the central challenge facing the whole industry today. The very process that makes our most important building material is also a massive contributor to greenhouse gas emissions. And that stark reality is driving a huge push for innovation.
And on top of the big environmental issue, concrete isn't completely invincible. Over time, it faces a whole bunch of other threats. It can crack as it shrinks, it can get damaged by the constant freezing and thawing in winter, and it can even suffer from chemical attacks from things like road salt, which can then corrode the steel rebar that's hidden inside. So while it's incredibly durable, it still requires some really smart engineering to make it last for decades. Which brings us to our final section, and my favorite part. How are we reinventing this modern marvel to solve these problems and get it ready for the next 100 years?
And the future here is it's awesome. Scientists are developing things that honestly sound like they're straight out of science fiction. We're talking about self-healing concrete that uses bacteria to literally grow and fill its own cracks. We're seeing giant 3D printers that can build entire houses with way less waste. There are even new types of concrete being developed that can absorb CO2 right out of the air as they harden, and brand new, greener cements that drastically cut the energy needed to make them in the first place. And we're also getting a lot smarter about what happens at the end of a concrete structure's life. Instead of just dumping it all in a landfill, we can now crush it down, use giant magnets to pull out the old steel, and then reuse all that crushed material as aggregate in new projects. It's a really key part of making the whole construction industry more circular and sustainable. So when you take a step back and look at the whole picture, it's pretty clear that despite its challenges, concrete isn't going anywhere. It is just too good at what it does. It's affordable, it's incredibly durable, it's fire-resistant, and you can mold it into almost any shape you can dream up. The real challenge isn't about replacing it, it's about reinventing it. And that really leaves us with the big question, doesn't it? Concrete built the modern world that we all live in. But as we look towards a smarter, more sustainable future, all those innovations we just talked about, they're going to be what determines if we can transform this ancient man-made rock into a material that's truly fit for the world of tomorrow.